Okay, Rishikesh, now you can share the details.
Yes, sir. So there is not such data available, but on few of the forums, they have mentioned like user experiencing lags and crashes due to their internet because 4K was something which was you consuming a lot of data.
Mhm.
That was one of the reason YouTube has done like they have the 4K is not available on it is only available on higher end devices like the
Mhm.
YouTube TV and some other devices which are like currently we are using which
Okay,
supports 4K.
okay.
That was one of the reason they told like
Mm.
that is mentioned. So the how does it performs users experience like internet connectivity, does it impacts user experience?
Yes, it will certainly impact user experience. Yes, so for example, if I'm in a remote village place where there is no 4G available, okay, and it's only 3G network available, and if I'm trying to access Amazon, my experience will not be as good as had it been with 4G network. So it absolutely plays a role. But then service provider or an maybe e-commerce website owner has very little control over that.
Okay,
Yeah. So what they do actually, they keep their websites very lighter, because they understand. See, ultimately, even if a remote user is not able to access, the loss is to the e-commerce website only, right? Or online application. It's not to
correct.
the user. Both are losing. User is not able to buy, and the vendor or supplier is not able to sell. So
Correct.
what they do, they typically keep their applications very lightweight, so that on 3G also someone is able to complete the buying or have a reasonably good experience. Yeah,
Yes.
so they try to take care of that, but there is a limitation. I mean, obviously, when you connect with 4G, you will have a different experience, right? Or
Yes.
use fiber direct to home. Nowadays, even Reliance is pushing for it. Airtel also is doing. So what they give you fiber connection at your home,
Yes.
which has a bandwidth of I mean, gigabytes per second, not even megabytes per second,
Megabytes.
right? So
Yes.
they will give you everything. They will give you TV channels. They will give you even one telephone connection. They will give you broadband, everything together. So it's a big pipe in terms of network, which they will give you the capacity wise I'm talking,
Yes. Um,
right?
yes. Got it. And
Okay.
that's why actually the question arose. Like I read about it, and that the only thing was the data connectivity issue, and that's why they introduced on very fewer devices. They are it's it is in an initial stage now.
Right, right.
They are
So, it's an ecosystem. For example, the good side effect of COVID is now there is broadband even in remote villages nowadays because people had to work from their homes, right? So they
yes.
were forced to work from their home. The network bandwidth got better,
Hmm.
and even government of India is pushing one program, right, in which they're trying to connect all the gram panchayat using high speed broadband connections and all.
Correct. Yes.
Mm, So
Okay.
overall, the user experience, but then the drawback of that is the expectations change from user. Right
Hmm.
now, you don't like if someone doesn't get loaded in 2 seconds. You say, "Arey boss, this is slow.
Hmm.
I don't want this," because your expectations are set now, and they are
Yes.
becoming more and more stringent.
Yes.
All
Okay.
right. So, as a practice, let us solve the assignment first. I have added one question on the fly, which we can discuss as an open discussion. Yeah, that is question number 3. So, who wants to start? Define performance testing, and you can actually read out whatever you have written. Yeah, that's okay. Intention is to make you read it, make you write it, so that you're able to answer the same way in the interview.
Shall I start, sir?
Yeah.
Okay, so performance testing is a non-functional testing done on a complete system, which is hardware and software,
Mhm.
which is carried out on a near to production like conditions. Second point is it is an intent to access if the system functions as per the performance requirement
Mhm.
or good user experience.
Yeah. So you miss the word reproducible because that is also
Yeah,
important. Yeah.
yes, reproducible.
So you should be able to execute the same test again and produce the similar result. That is
Yes.
reproducible. That
reproducible.
is the key point, and then you can talk about, okay, sorry, you can continue.
So, okay, sir, I will add my reproducible, and also it measures various key performance parameters like response time, throughput, and user concurrency. Also, performance testing identifies bottleneck in the system, and we can retest the performance defects to validate, and if they are fixed, like we can fix the performance defect, which will reduce the risk of failure during performance issue. Like,
Yeah. So I'll quickly check. Yeah, and performance testing reduces risk of failure in production due to performance issues. Yeah, that is also you should add. So
yeah.
basically, हे तुम्ही पाठ करायचंय. Okay, now one word here and there, it's fine. But then there are some keywords which you should be remembering, like complete system, it's a non-functional testing, near production like conditions. And we ensure that system data, number of users, background noise also gets reproducible, right, as per near production. And then the rest of the points.
Yes.
Okay. Next, list down key differences between functional testing and performance testing.
Yes, Manisha here. Sir, the difference between functional testing and performance testing is, first of all, we'll go look after the different aspect that it is very much easy as compared to the performance testing. Then the objective is that the correctness of the nature of the function. We have to test the correctness of the nature of the functionality in the functional testing. And in performance testing, we have to accept the behavior of the whole system. That is for the hardware and the software also. Precedence typically done before performance testing. The performance testing is functional testing should be done before performance testing, and performance testing is done after the functional testing.
Yeah.
Execution in functional testing, we can go through manual also, and automation tools also are available. But in performance testing, we have to go for automated tools only.
Yeah.
Infrastructure size is small as in functional testing as compared to the performance testing.
Yeah.
Then defect are less costlier in functional testing, but in performance testing it might be more costlier. Then skills for functional testing should be for in most domain knowledge and test process.
Yeah.
Though that in performance testing, technology plus test process plus domain knowledge should be there. Then
so when we say technology, what we mean here is a good understanding of database queries, ability to write scripts, good in programming, very basic programming, but that's what we mean by technology. And person should be able to understand. So technical understanding should be more when we say technology, because technology is very high level word.
Right.
So what we mean is that you can refer to our skills. Person should be knowing at least one good programming language, able to prepare scripts, right? Should have good understanding of database and SQL queries and overall architecture of the application.
Okay.
Yeah.
And the requirement gathering is very much difficult in functional testing, but it is more difficult in performance testing.
Yes. Now the reason here is because most of the time they are not available. So you have to talk to so many people and then arrive at non-functional or performance requirements basically. Yeah.
And the examples are integration testing, system testing, E2E testing is for in functional testing, and in performance testing it is a load test, then test testing, spike testing, soak, endurance testing.
Yeah.
These are the difference between functional testing and performance testing.
Correct. So these, as I mentioned yesterday, these are levels of testing. Okay.
Right.
But then you can also say sanity also is type of functional testing.
Okay.
Right? Or smoke testing also is type of functional testing.
Okay.
Okay. So hope you have understood this.
Yes,
for
sir.
example, you might be cross-questioned that why you feel that performance defects are more costlier. Okay, as compared to functional defects. right? So
But
basically,
sorry.
yeah, sorry, you can answer.
No, sir, fine, no issue.
No, so you can
Actually,
answer.
after because
No,
what we are
so that-
doing, sir, functional testing is that we are testing one by one module, then we will integrate it. And what we are doing in unit testing, we will get some bugs and everything by the itself by the developer. So the time consumption is very much less as and in performance testing, what we are doing after completing full, that is a module, or we can say of after integration testing and system testing, we start performance testing. And now if we find any bug at that time, it will be very much difficult to debug and to find the fault, where the fault in the system.
correct. And the efforts typically required for performance testing are very high.
Yeah.
Okay, and when this bug reaches the production, then we might lose customer because our application has become slow, the page is not loading.
Right.
It can be so many reasons basically. That's why it is more costlier, because it is first more costlier to fix also, and it gives you bad reputation, that this website is very slow. So people will not come back to our website.
Yes, sir.
And in general, we do performance testing on bigger environment size, right? So investments also is on high side. That can be one more reason. Okay, let's move to next. So we will first cover true and false, and then we will look at, why performance. So basically, answer to this why performance testing is done will overlap with define performance testing. We can choose some points from there, and you can make your own answer. But then we can discuss that. So let's go through true and false. So application needs to be functionally stable to start performance test execution. True or false?
True.
True.
Archana, what do you think?
True, sir.
Okay, yeah, because we first do functional testing. If there are no functional defects, then we start performance testing. Because during performance test execution, if we see any functional defect, then our performance test execution cannot get completed because it gets stuck. And that's the reason we should not do performance testing before functional testing. Next, better performance of an application guarantees good end user. Now, one by one, you can answer, not all together. So, Shraddha, what do you think? Better performance of an application guarantees good end user experience.
So it is true. If the performance is good, then user will have a good experience. If performance, like if website is taking more time to load the page, then end user will be ultimately frustrated. So his experience will not be good. So the performance of application matters a lot.
Okay. Now, this is a little tricky question.
Okay.
In a sense, end user experience is not just performance.
Okay.
So I'll draw something here. Just give me a minute. So if I consider this is a user experience pie chart. Let's put end user. Experience. So now if I ask you all a question that what do you think is a good user experience based on your opinion, what are the different factors you will expect? Now let's look at your actually using an e-commerce website. Yeah. So what will make your end user experience good? Can you give me your own view? So Archana, what do you think? When you will call that this website is good?
Time required for loading the page and speed of that website.
Okay, so I'll say performance. Is that all? If your website calculates wrong amount, are you okay with it? For the order, you have placed one order for one nice dress. The dress amount was shown as 500, but in your order now it is showing 700. Website is absolutely fast, no issues. Will you be happy?
No, sir.
Okay. Now let us say that website is fast, but you have to go through, 10-15 pages to place an order.
Usability
No,
should
that
be
is
considered.
Usability. There are a lot of other factors, For example, they have used some horrible color on the website. They will not do,
True,
but
right.
then you don't like the appearance and all. What else you will look for?
So security.
Yes. So security in a perspective that others are not able to see what you're buying, from a website. That your connection is secure, right? You're not getting any viruses when you connect to that website. That's what we mean by security. Right? What else?
Objectivity.
What do you mean by that?
It's pretty much clear, like whatever functionality is mentioned.
So I'll try to put that in usability, because it's very
yeah.
clear that so you can use it very easily.
Yes. Okay. Mention.
Anything else?
A rating for that particular application, what product or anything, reviews.
Well, but then if it is good, anyways, reviews will be good.
Hmm.
If it is bad, reviews will not be bad. Will not be good.
And the transaction time when we are,
So that I will put in performance.
okay.
So
So
anything
scalable.
related to speed, that also will be part of performance, because then that should be taken care by their performance architect and performance testing team, right?
And
So I just started putting some aspect. There can be many more which we are not able to jot down now.
Sir,
Okay.
maybe can I go how it will be behave on laptop, different devices,
Okay.
mobile, and then on the
So what is it
laptop.
called? What is it called?
there's different platforms.
It is called portability.
Portability.
Hmm.
Yeah. So how portable it is? Can I use it from my laptop, from my desktop, from my iPod or whatever, iPad, iPhone? Yeah, obviously all will not carry same weightage. Some of them will be more important, some of them, but then they will add to end user experience quality overall. Correct? So just performance will not guarantee good end user experience.
Okay.
Correct? So that's what I had. It is little tricky. Better performance in application guarantees. No, it will not guarantee. It is good to have, but then, so in mathematics, we have learned, right? It is necessary, but not sufficient. So this is necessary, but not sufficient. Now, next is, so hope you understood. So good end user experience includes good performance. Okay. But then there are so many other factors as well along with it. Yeah. So as a performance testing team, what we should do, our job is to ensure that all the aspects of performance are taken care. Right now, the usability, aesthetic, there are different teams to take care, but all of them will make good, end user experience good or bad. Okay. Now I have next. Good end user experience guarantees better performance of an application. So Archana, is this true or false?
True, sir.
This good end user experience. So here I had asked better performance guarantees good end user experience. And we saw that no, performance is just one part of the end user experience. Now next is good end user experience guarantees better performance of an application. Is it true or false?
True.
Yes, you have to give reasons when we say true or false.
When user get good app and all, then it will be better for the performance of the application.
Okay, so we just saw here, so when this whole stuff is good, that means all of them have to be good. Then only all end user experience would be good, isn't it?
Mhm.
Yes.
Yeah. So I have asked exactly opposite question here, that good end user experience, right? So experience is good. So that implies that the performance also will be good. So that is true. So your answer is correct.
Yeah.
Yeah, because end user contains performance and many other things.
Yeah. The feedback of the end user is also affect the performance of the application.
Correct. So when end user says this is all good, so that means he's happy with the performance also
Yeah.
indirectly.
Yes.
Yeah. Okay. Next is performance test execution is always done in automated way. True or false? Shraddha?
True.
True. Okay. Why?
Because to check if
Yes,
tool
Shraddha.
which will give.
Sorry, I could not hear you in between.
Okay, it is true because to check response time or throughput, we cannot do it manually. We have to use some automated tool which will give us numbers.
Okay. Yes, that is one justification. Another is that, typically in performance testing, we try to simulate near production conditions. For example, in production, let us say 3,500 users are logged into your application. So we have to test it the same way in performance testing,
Yes.
right? So we cannot have 3,000 testers available for testing. That's why we have to use the tool, yeah, which is have an ability to create threads.
Yeah.
So it's both. I mean, utilization also, or response time also. We can't compute manually or watch. Plus the number of users also not feasible.
We have
Right?
to
That's why-
simulate the real-time
Correct.
experience.
Correct. So that's the reason there is only automated way to execute performance test.
Okay.
Next is lower the performance, more the bounce rate for an e-commerce website. Manisha?
Sir, it's true.
Okay. Why?
Because if the performance is low, the maximum customer will be not going to that site.
Correct. Correct. So bounce rate means first you can explain when a consumer or a customer leaves that site with a bad taste and never comes back, is bouncing off.
Okay.
When the performance is lower, naturally more and more customer or consumers will be unhappy and they will not prefer to come back to the website. So this is a correct statement.
Okay.
True. Okay, next, performance test execution can easily be done on functional test environment. Rishikesh.
It's false.
Okay.
So basically, performance testing is being done on near production line infrastructure, which is much bigger than the functional infrastructure.
Yes, correct. Yeah, because in performance testing, we actually consider the whole system for testing, hardware plus software. Whereas in functional testing, hardware is not counted, right? We just look at the functionality.
Yes.
So if we try to do performance testing on functional test environment, it will not be able to sustain that load and it may crash. So when we say crash, that means the server may become unresponsive, the application will hang, it will stop responding, and we might need to restart the whole infrastructure again. That's why it is not recommended to do performance test execution on functional test environment, because they're very small in nature, in size, whereas the performance test environments are bigger in size.
Bigger in size.
Okay,
Yes.
cool.
Hello, sir.
Then, yeah,
In functional testing, can we only testing in the software, no hardware?
no, sorry, who's speaking?
Archana.
Yeah, Archana.
In functional testing, only we testing software, no hardware testing is there.
No. So you never even look at what the hardware is below, what's the CPU memory, you don't care. What you see, suppose you're testing a login functionality. So you will write test cases for wrong password, invalid username, and you will test all of them. Yeah, but
Okay.
then you will not be bothered about what is the size of environment, which is, where the application is hosted.
Okay.
Okay, so have you joined 3 groups?
Yes, sir.
Yes, sir.
All of you?
Yes, sir.
Sir, I have not. I will join today.
Okay, okay. Because then you have to start reading the paper, whatever issues or problems people start sharing, so that gives you a lot of learning, from others' experience. So whenever you face issue, you can also share your problems and that group, and someone within a group will, share back with you. Okay, now I added this question: why performance testing needs to be done? So we defined performance testing. We have talked about, so many things in true and false while discussing. So why you feel performance testing needs to be done? Yeah.
Sir, it guarantees you the very good user experience.
Okay.
That's one of the point. So also
It will not guarantee, but then it will give us very good confidence that our user experience is going to be good because we have
Good, yes.
tested it ourselves.
Yes, sir.
So, I mean, again, if we don't do performance testing, then our application may fail under the load in production, right? That may lead to, a lot of user inconvenience, bad user experience. User may stop using our application. We will lose revenue. There are so many issues.
Hello.
Yeah.
It will generate more revenue
Yes,
to
correct.
the
So if we
organization.
do it, then we are confident about our application performance. Yeah, and if we
Yes.
continue to do it, naturally our performance will be better for the applications and we can get more revenue. That's correct. So positive side of why we should do it, So the negative side, if we don't do it, we may lose revenue. But if we keep on doing it, if we keep on fine tuning the application, our revenue also will go up. Correct. Yeah. So
Sorry, it reduces risk of failure.
correct. But then ultimately that will lead to bad user experience, right? So when we
Okay.
say bad user experience, it covers the risk of failure also. But
Okay.
you can add it as a corollary point. Yeah, because if we do performance testing, we identify issues in testing itself so that those issues will not occur in production and they will not impact the end user. Yeah. So ultimately it is again to the end user experience related to revenue and bad name to the company because people will not like to come back to that particular application. They will not prefer to use it because it's very slow. So all leads to revenue loss, all leads to losing market share. Yeah. Okay. So when we do performance testing, our confidence is high, that how our application is going to behave in production. When we don't do it, we don't know what is going to happen. So it's very uncertain. Yeah, so that adds to your confidence of the whole team that our application is behaving well with whatever thousand of users we have tested. So it will be behaving equally well in production as well. Okay, so I think that completes our assignment. Is the updated. Okay, so let's start with today's session. So what we are going to cover today is terminology and basic concepts. Yeah, so the terms which we use in performance testing, what's the meaning of it, what's the importance of all of them. So this is readable, right? Good to start.
Yes, sir.
Yes, sir.
Okay. So, when you start working as a performance tester, you will come across a lot of terms, which your colleagues would be using, maybe the seniors would be using. If you don't know meaning of it, you will not be able to enjoy what you're doing and work. Right? Same thing happened when you started your functional testing, right? If someone said, regression testing, do regression testing. And if you don't know what is regression testing, you will say, oh, what is that? I'm doing it, but I don't know why it is required. So that's not a good situation. So whenever you enter any new field, the first thing you should be comfortable and learning is to terminology, so that you start using the same words, right? So for example, when your lead tells you, can you update the test plan? You should know which document he or she is referring to, right? You should know what are the typical sections in a test plan, right? So it is important to understand the concepts for any new field where you enter and which are fundamental, right? And you should understand the meaning of them. It's not just you're familiar with, the terms. You should know in and out meaning of this, why it is done, when it is required, why it should not be done this way or that way. So if you don't understand meaning of these terms, you will not be able to work as a performance tester. Yeah, because then people will start, he doesn't know or she doesn't know. I mean, that's not a good impression. Correct. So let's spend time today. There are a lot of terminologies I'm going to cover. It may be overwhelming, but then, I mean, that's okay. You will get used to it. Don't worry. Okay. So let's start with, there might be some theory involved. So you have to just memorize when it comes to theory. When there is a concept, you can try to understand, use your own reasoning, your own earlier understanding, try connecting dots so that you understand the concept well. When you will start actually working, you will have a better clarity on those concepts. Yeah. So performance objectives. Now, what is objective? Something which we are trying to achieve, right? So when we say performance objective, this is what, we are trying to achieve. Now, what are the examples of performance objective? Response time, throughput, and resource utilization levels. So response time, we will have a look at it. But then, as you know, in general, response time is the time taken for any application to respond to your query, whatever you have submitted, right? Throughput is transactions per second. It is always measured in transactions per second, or maybe transactions per minute, transactions per hour. But what we are basically checking, how application is churning the transactions in terms of completing those transactions, processing the transactions. Resource utilization levels are typical. The two broad levels are CPU and memory, and there are many other performance related factors which we consider. But at high level, you can think of CPU and memory when it comes to resource utilization. So what levels of these parameters we are trying to achieve? They are called performance objectives. So you may have a performance objective that response time, average response time should be less than 5 seconds. That is one example. Or throughput should be, 100 megabytes per second in terms of bytes, or 35 transactions per second. It can be any, right? Performance requirements. Now we all know requirement basically describes what is expected, from a software. So when it comes to performance requirement, they describe how your application performance should be, what is expected performance of an application. And how does it, how do you describe, performance of an application? You can define it through performance metrics, right? Now, again, these requirements may not be available. So you have to work on your own requirements by talking to users, talking to, database, architect, user, your client, and then you can formulate these requirements. Now I have given some examples here. Yeah. So any product search on an e-commerce website should be complete in up to max 5 seconds for 90% of the time. And this is also called 90th percentile. Okay, so what we are saying that any product search, yeah, so on this e-commerce website, when I am doing a product search, any product I search, I should be able to get results in less than 5 seconds. Yeah, because it should take up to max 5 seconds and 90% of the time. So if I do search 100 times, 90 times, I should get the search complete in less than 5 seconds. Only 10, out of 100, maybe on 10 instances, it may take 5 seconds or more. Next requirement example is batch job to process inventories should be complete in max up to 2 hours for 99% of the time. So you'll always say I'm attaching some percentage. Yeah, so that is the way your requirement should be very clear. Because if I say, here batch job to process inventory should be complete in 2 hours. That's it. I don't say 99% of the time. Okay, so that means every time it should get completed in 2 hours. Anytime, whenever you try, max 2 hours. But then sometimes it may go beyond 2 hours. So what is that tolerance? Only 1% of the. So if you take a data of this batch job for 100 days, you are running it for every day. So only once in 100 days, it's okay if you exceed 2 hours. Otherwise, by 99 days, it should be completed in 2 hours. So any requirement which you give in performance testing or gather needs to be very clear and crystal clear, so that based on this only you are going to tell, whether your performance requirements are, where they are achieved or they are exceeding or they are breached. Another example, application should be able to handle up to 500 concurrent users in peak processing hours. Yeah, so 500 concurrent users means those are the users which are logged in, they're using the application, right? So in a peak hour, when there is a maximum rush, application should be able to handle up to 500. So it may, if there are 400 concurrent users, still it will be able to behave properly, give proper response time. Yeah, beyond 500, maybe it may become slow, or it may start hanging, or there can be any other issue. Application should be able to handle up to maximum 50% more orders than that of average order. Okay, so what we are saying, so average number of orders every second is 200. So on an average, there are 200 orders. Okay. But then if number of orders go up by 50%, that is they become 300 orders per second, our application should still be able to handle it. Yeah, without degrading response time, without hanging, without crashing. Next example is web service should fetch data in less than 1 second for 99% of the time. Yeah. So we always attach this, because if we don't attach, then that means it should always fetch the data in 1 second. And that is little difficult to commit, for any software vendor. Database, or they may say 99.99 also, which is still fine. So what we are saying, if I execute this web service, 1000 times. Okay. So out of the 1000 times, for 990 times, it will give me the data in 1 second. And maybe 10 for 10 instances, it may exceed. Yeah, so we are always becoming practical. We are not just saying that, no, it should always bring it in 1 second. Database query should fetch data in less than 500 milliseconds for 95% of the time. So you will see there is no confusion when we read these requirements. Yeah, now obviously database query, which query and all, that is a different thing. This is just an example, how you can mention the performance related parameter. Okay, so these are some of the examples of performance requirements, where we are talking of some batch jobs, some web services, some database queries. But everywhere we are mentioning, less than, up to, max, so that we are clear. It's very crystal clear when we test it. Yeah. Next is performance test environment. So this is a test environment used for doing performance testing, especially the execution. Yeah. So performance test environments are typically bigger in size as compared to dev or other type of test environment. So you may have a system integration testing environment, system testing environment. Yeah, there are different test environments. There are development environments also. But performance test environments are bigger than these other test environments. So typically performance test environment, which is 50 to 60% in size as compared to production environment, would be reasonably accurate, because as I mentioned earlier, building another production size environment is very costly. Yeah, no, generally companies will not do that. They'll say, boss, do you really need another production size environment? Because it's so costly, you have to invest so much. Yeah, so basically 50 to 60% is a reasonably practical size. It's not too costly and the environment is not too small also. So while comparing environment sizes, we typically compare the processing abilities of the environment. Yeah? So we compare CPU, memory, and as they have significant impact on performance of the system. Yep, so this is brief about performance test environment. Now let's look at, so I've just drawn some diagrams here so that visual is always easier than a text. Yeah, so when we look at performance test environment, it will have a tool for executing performance testing. Then it will have web service, a web server, database server, application server. So it is basically a collection. Any test environment is a collection of hardware, software, network, tools, test data, configuration setting. So it's a collective entity, any test environment. So performance test environment also is collection of hardware, software, network, tools, test data, configuration setting, test harnesses, that is stubs and drivers. It can be hosted on cloud or it can be using physical hardware resources. Yeah, so as I mentioned, majority of the IT companies are moving towards cloud. Yeah, so they'll be either using 3 of the market leading solutions: Amazon Cloud or Google Cloud or Microsoft Azure. Yeah, so performance test environment can easily be hosted on cloud. And it is a collection of hardware, software, network, tools, test data. So any questions on whatever I have covered so far?
No, sir.
Okay. All right. Next is performance baseline or benchmark. Okay. So basically, when we say benchmark or a baseline, we can compute the response time, system utilizations under specific load condition, and we will say, okay, this is a benchmark for this release. Okay, now next release we will again do the same thing and we will check whether the response time remains same, the system utilizations remain same, right? Because the software is undergoing changes, right? So whether those changes are putting any negative impact on the performance or not, that we are checking. So typically when we do release over release performance testing, we can use performance baselines, benchmark. So we will actually prepare a table, okay, that for September release, these are the values of response time and system utilizations. We again execute the test in October, but there is some code change. So that time we'll again put those values and we'll say, okay, now response time was earlier 5 seconds, 90th percentile value. Now it has become 5.5 or 4.5. So which is okay, not a lot of variation. If it becomes 9 or 10, then there is a problem. Okay. Performance SLA, we all know SLA is service level agreement, which is actually a commitment, from the system or application about performance metrics. Now, one good example of SLAs, not performance SLAs as such. If you look at any of the cloud website, cloud provider, if you go to Amazon, if you go to Google Cloud, if you go to Azure, Microsoft Azure, they will give some SLAs that our cloud availability would be 99.99%. So that is their commitment. If it goes below that, then they are liable for penalties. So that's why these SLAs are important. So whenever any product vendor launches their product, they come with some SLAs that we guarantee you that this is our performance. Our response time will not go beyond 3 seconds anytime. So that can be for 99.99% of the time. Yeah. Performance metrics. Now we know any metric is ratio of two quantities. So when it comes to performance, response time, utilization, throughput are typical performance metric. These are three broad level, you can say. Yeah. So performance targets and goals. These are similar to objectives. That these are desired and expected values of performance. What's the response time? What is the throughput? So objectives and targets and goal are almost synonymous. Yeah. You will come across term called, now these are not alphabetically, or they are not collected. Wherever I thought I need to include this, students should know this, I've added. So there might be some non-related terms here. Yeah, so synthetic monitoring and real user monitoring, or RUM. You will hear this in production. Yeah, so synthetic monitoring, where we actually create a setup environment and with some automation tooling or performance test tooling, we will do monitoring. Whereas real user monitoring, we actually look at production and performance of a page from a real user machines. Yeah, so synthetic is more fabricated, arranged, simulated in laboratory. Real user monitoring is actually done on real users machine basically. This is for monitoring various parameters of application, like utilizations, any query taking longer time or any page taking more time. So they will monitor all of this. Performance test plan or a strategy. So we all know for functional testing, we have functional test plan, right? So similar to that, there is a performance test plan. It obviously, we looked at, yesterday, performance test life cycle. There are a lot of differences when it comes to workload model, which is not there for functional testing, environment sizing, which is not there, right? The test data amount is very huge for performance testing. So performance test plan will ensure that all those attributes are taken care. So a typical performance test lead would be preparing this test plan, and it will contain all the sections which are required to implement all the testing efforts towards performance testing. Workload model. Yesterday we looked at workload model for my bank, right? We want to understand how many credit card related transactions we need to simulate, how many login, log out, how many account related, right? So it is a load pattern which represents actual usage of a system in production. So in production, if we take an example of let us say any inventory system, right? So we want to do performance testing of inventory system, inventory management system. So we will actually look at how many types of transactions are there, what is the volume of each transactions happening in production or expected to happen. Yeah, so we'll prepare a table in which we'll say, okay, these are the transactions and these are the volumes of each transaction. So that is a workload model. Yeah, so it is a collection of various parameters like transaction volume, how many transactions are there, then how many users are logged into the system, then are there any batch jobs being run at the same time on production. So workload model will contain all these details because we want to simulate exactly same thing when we will do performance testing. Yeah, so workload model is very, very key term. You will come across in every project, in every release. They will say, hey, have you looked at workload model? Because based on that, you have to set up your scenario for execution. Yeah, so you should have a good understanding of what is workload model. It's a tabular form. It's not very complicated and hi-fi rocket science. Okay, what we're trying to understand, what all we need to simulate. How many batch jobs need to be run in parallel, right? How many external systems are putting load? What type of load? Are there any web service call? So we want to understand everything so that we simulate the same thing. Yeah. Throughput, another important term. Number of transactions system can process in unit time. Yeah, it may be expressed in per second, per minute, per hour basis. The time is calculated from the start of the first sample to the end of the last sample. So it is typically known as TPS, throughput, transactions per second. That's a short form, TPS. Yeah. So throughput is number of requests completed divided by total time. Now throughput is typically applicable to server because server processes the request, isn't it? So browser will not do that. So browser will be sending request to the server. Server will be responding. So how many such requests server is able to complete or handle in a given time? So some examples I have given. Server is processing 15.5 book flight transactions, 19 cancel flight transactions, and 27.3 search flight transactions per second. Now this may not be complete number, okay, because you are dividing it by total time. So it may come in some decimals also. So which is fine. So you can always approximate, right? You can say, okay, approximately it is processing 15 orders to be on safer side, 19 cancel flight and 27 search flight transactions. Another example of throughput is application server processes approximately 1,75,000 customer records per second. Yeah, so a file is coming from an external source and we have to validate those records. So our server is able to validate 1,75,000 customer records every second. Okay. Next example, if a packet with the size of 200 bytes takes 1 second to flow from computer A to computer B. Yes, I'll repeat, 200 bytes. It is taking 1 second to flow from computer A to computer B. So what we can say that the throughput between the two devices is 1600 bits per second because we know 1 byte is 8 bits. So 8 into 200, 1600. So every second 1600 bits are flowing, right? So that network, the throughput of that network or bandwidth, we can say, not bandwidth, the utilization. So 1600 bits per second. Yeah, so this becomes a throughput of the network for 1 second. So that is unit, right? So here also we are saying per second it is actually processing 1,75,000 records. Per second it is processing so many book flight transactions, cancel flight transactions, etc. So is throughput clear?
So
So-
the last point I did not get, the packet with a size of 200 byte. How
Okay.
come this?
Yeah, so what is the question?
So how it is 1600? I did not get it.
Yeah, so 200 bytes means 1600 bits, isn't it?
Yeah, yes.
And it takes 1 second to flow. So per second, it is 1600 BPS, bytes per second. Yeah, so if I say 2 seconds here,
Mhm.
then I have to divide the whole 200 byte into 8 divided by 2. Then it will become 800 bytes per second. Bits. So see, this is always calculated as bits per second. So when I say I have got 100 Mbps connection, I'm talking of 100 megabits per second, not bytes. Yeah. So because it took 1 second and it's 1600 bits, that is 200 bytes. Yeah, that got transferred from between two devices. So per second, how many bits are getting transferred? 1600, correct?
Yeah, bit.
So that is a throughput.
Yes. Okay. Thank you.
Archana,
Sir,
any queries?
No, sir.
Okay.
sir, I
Yogesh.
have one. Actually, is the packet size variable? Like it's mentioned 200 bytes over here. So does it vary?
No, I think it is standard, right?
Okay,
So 1 byte
200
is
bytes.
equal to 8 bit, and I think there will be a standard size for each bit.
Yes, sir. Yeah, in terms of like it is mentioned the size of 200 bytes. So will it vary from computer A to computer B? The throughput.
No, no, no.
Okay.
Because bytes and bits are very standard. They will not change across the system.
Sort of packet. Okay.
So the size will always be 200, or will it vary like 300,
Yes.
400?
Yes, that's also
No, no.
question.
So for this instance, so what I understood is whether a size of byte, the size of byte will not change. For example, if it can transmit 400 bytes after some time,
Mhm.
okay, then the throughput will become 400 into 8, 3200 bits per second. So this is
3200.
200 bytes flowing. The throughput is 1600 bits per second.
Okay.
For
So
this,
as an example, we take 200 byte.
correct.
Okay.
Okay.
So these all are examples. I mean, for that instance, this is happening. Okay. Next is bandwidth. So network capacity to transmit. So bandwidth is typically related to a network. Okay. So how much data can be transferred over a network? You know, the maximum size or rate of that data transfer is bandwidth of that network. Yeah. So 6 Mbps, which is a broadband connection. So what it tells that I can maximum carry 6 megabits per second. Yeah. So that is the capacity. Are you getting?
Can you please repeat?
Yeah. So network capacity, the max it can carry for a network. Okay. So that it says it is 6 Mbps. So when I have a broadband connection of 6 Mbps, that means my connection will be able to carry 6 megabits per second. Every second, it will be transferring 6 megabits. Mega is 10 raised to 6. Yeah, and if it is fiber network, it will talk of terabits per second or gigabits per second. So capacity of the network to transmit data and the maximum rate of that data transfer across a network. So how much max it is carrying? That is called the bandwidth of that particular network connection. Yeah, so basically the bandwidth can be 6 megabits per second, but maybe you are getting a speed of 2 megabits per second because it is not utilizing the whole bandwidth as of now. I think bandwidth is, you would have covered, if you're an electronics engineer, you would know bandwidth, right? In your curriculum.
Yes, yes, sir.
So it's not different. The same thing I'm discussing here.
Yes.
Different concept. Okay. Yeah, I think I will take a quick 5 minutes break here now. We have just 1 hour in the session. Yeah, so I'll come back because this is something different. I'll
Yes, sir.
just sip some hot water and I'll come back in 3 to 5 minutes.
Yes.
Okay, sir.
Okay. Now this is little more related to, more deeper terms. Now, yesterday we used bottleneck, right? So what is bottleneck? So it is an element of a system which negatively impacts the system performance. It is the slowest processing unit of the system. Okay. Now, when we say slowest, so we all know, right? For example, if we are standing in a queue, okay, and we are passing some packets to each other, one after another, and one of the person is not able to transfer. So what will happen? The queue will get slower at that point, right? Because he or she is the slowest unit of the whole system. Is not able to keep up the pace with others, the way others are passing the packets, right? So it can be a database query, which is a bottleneck. It can be a code snippet. Snippet means some part of the code. It can be a bad job. It can be, poor memory management of the code. Anything can slow down your system, right? So pictorially, I have just shown you are sending some input. This is the bottleneck, because let us say we are sending some maybe air or fluid from this chamber, right? So at this point, it will become very slow. Slow in a sense, so air has to stop somewhere because it cannot pass the way cross section is here. It is not here, right? So output will be decided by how much can be flown through this, not how much can flow through this. Yeah, hope you all agree. So if you see, bottleneck is always smaller than the whole bottle. And when you pour something, whatever comes from the bottleneck, that only you will get, right? So that becomes the throughput of your bottle. Hope you are getting what I'm trying to say here.
Yes, sir.
Archana. Okay.
Yes,
Now
sir.
let's look at some elements which are becoming bottleneck. So this is a CPU, okay, which is receiving 10 requests per second. Okay, but then CPU has a capacity only to process 5 requests per second. So what will be the output of this CPU? It will be processing 5 requests per second. Whatever the system is sending it are 10. So system, the rest of the system before the CPU, it is processing 10 requests per second. So 10 requests are arriving to this CPU. CPU says, wait, I cannot hold and handle 10 requests. I'm going to process only 5 requests because that is my capacity. So what will be the output? Output will be 5 requests per second. So even if the rest of the system is able to process 10 requests per second, when everything reaches this CPU decides because it is slower than the other system. That's why this CPU is a bottleneck. Yeah. So if you increase the capacity of this CPU to 10 requests per second, we will be able to get 10 requests per second output here. But right now we are getting 5, whereas the rest of the system is able to process 10 requests per second. So what we can conclude, this CPU is a bottleneck because it is slower than the rest of the system. Understood?
Yes, sir.
Manisha,
Yes, sir.
Archana,
Yes, sir.
okay. Rishikesh,
Yes, sir.
okay. Let's take another example. Now this is a database. It has a 2-second response time. So whenever we fire a query, it generally takes 2 seconds to respond back. There is a web service. So this is a typical architecture. Okay, this is a UI, that is a user interface, which will invoke a web service. Web service will fire a query on database. Database will respond back. Web service will give that back to the UI, which will get displayed. Now this web service can make one call every second. Yeah. So this can make one call every second. But then whenever it makes one call every second, database takes 2 seconds to respond back. So suppose it send one call to database. Can it send immediately next call? No, because database says, no, hold, I'm waiting. I need 2 seconds because that's my capacity. I need to go through so many tables. I'm going to take 2 seconds. So when we actually fire a web service or something we send from UI, web service will get called. It will make one call every second, but it has to wait because database says, no, hold on. I cannot respond in 2 seconds, 1 second, right? So it will make one call. It will wait. After 2 seconds, it will get the response back. And then it will send it back to the UI. Yeah. Now, if I tune this and I make this 1 second or I make this 0.5 second, so then will the system become faster?
Yes, sir.
Yes.
Yeah. So right now, because of this 2 seconds, it is dragging the whole performance of this particular application to minimum 2 seconds. 2 seconds plus, because this web service also will need some time. So that means this database query which is taking 2 seconds response time, is a bottleneck. So bottleneck is something which is relatively slower with respect to other components of the system. Now let's look at this. Now, this is a connection pool. Now connection pool is one configuration in every server. Okay. Now we have actually set this connection pool randomly to 3. Okay. 3 is not possible. You have to set it in some multiples. But for sake of the taking example, I've said, okay, we have set it to 3. Okay. And there are 5 connection requests made. Yeah. So 5 connection requests made, but our connection pool can handle only 3. So 2 have to wait. Only 3 will get access to the server. Right. So our system is able to send 5 requests to server for connection. Connection pool says, no, I cannot handle. You have to wait. That means the connection pool configuration or an element in the system becomes a bottleneck. Yeah, so we have to find such slowest part of the system and we have to tune them so that the overall throughput of the system improves. For example, here, increase this 5 requests per second, maybe upgrade the CPU, add one more CPU so that now there are 2 CPUs. So that means then we will be able to get 10 requests per second output, isn't it? Similarly, here I will tune this database. I will say, let it be 0.5 second. We'll tune it. So then one call every second. Within 0.5, I get response. Next second, it again makes next call. Here, I work on it, I make it 10. Then I'll say, okay, I can give, connection request to server for all 5 connection requests which we are receiving. Yeah, so this is the concept of bottleneck. So when we see such bottlenecks, we identify them. What is the issue? Is it a queue is a problem, or is it any setting on server a problem, or is it just CPU getting saturated? So when saturated means it is 100% utilized. It has a capacity of 3 have been utilized. Any questions on this?
No, sir.
No,
So
sir.
that means we are checking the bottleneck for software as well as for the hardware,
Yes.
like server and okay.
Correct. So bottleneck can be anywhere.
Yeah.
So,
Okay.
when you are speaking about UI, so whenever we are calling the function, whether we have to decide the for per call, we have to decide how much second it will take or what, sir.
So can you repeat your question?
When we are, if I'm having one UI
Mhm.
and in that I have to call 2 or 3 functions. So for
Mhm.
one call, if it for one call is per second we are saving. So I want to ask just for the information, for each and every call, whenever I'm entering anything and I want that particular, it should be displayed on UI. So for particular, for every parameter, is there a time set for that? How, at what time it will get displayed in 1 second, millisecond, or whatever it is?
No, I did not get your question. So this web service has nothing to do with what is getting displayed on UI, how much time it takes.
Okay, that's I want to ask.
Yeah, no.
Okay.
So that I have not included in the discussion because then that will become complicated. So every browser has something called rendering time.
Okay.
Okay, but then I don't want to talk about that so early. We will discuss about it little later. Yeah, so
Okay.
this is just for the sake of showing you this is slower than this. That is the intention.
नाही म्हणजे मला तेच विचारायचं होतं की जो पण आपला युआय असतो त्या युआय वर जे पण आपले पॅरामीटर्स डिस्प्ले होतात म्हणजे जे पण आपल्याला येतं म्हणजे जसं एखादं बिल आहे तर त्याच्यावर आपल्याला बिलवर आपलं नाव हे ते जे काही प्रॉडक्टची एंट्री तर ते यायला काहीतरी किती वेळ लागतो हे सगळं प्री डिसाइड असतं का सर? म्हणजे
नाही, that depends on when your browser receives it from the network.
Okay.
Browser job is just to render it to you. So
Okay.
browser may spend some milliseconds in doing that.
Okay.
So browser also is a software, but if it doesn't receive that information, it will show you blank page or
Right.
something white or some black screen or something. Yeah.
Okay. Thank you.
Okay, next is response time. So time taken by system to respond to any user action or query, right? So it can be a click on a button, it can be a submit, it can be, clicking on a URL, anything. So for example, observer is typically I'm using a browser, right? So I'm the observer. I want to know. Okay, so when I send something, it will flow over the network. It will go to the server. Server will need some time to fetch the resources for me. It will send it back. It will be delivered to me. So response time is T1 plus T2 plus this T3. So how much time it takes to go to the server processing time in terms of fetching the resource, and T3 the time it required the resource to reach out to me. Yeah. Now again here I have not considered the browser, so it is included. You can say it is part of T1 or T3. Yeah. So when it starts here, it reaches here. So T1 plus T2 plus T3, that is the response time. So typical response time can be a wait time also because you are not doing anything else. So if it is sub-second, you don't mind. But if it is 3 to 5 second response time, you will say, hey boss, I'm just waiting when that, logo will get displayed, when my submit button will get displayed. You'd have experienced this. Sometimes website is so slow, it starts showing you one element after every second. It doesn't show you the full page in one go. Yeah. So from an observer perspective, I clicked a button and I saw the image which I wanted. So whatever time from the button I pressed till the image I saw is response time. It will include time taken by network both ways plus time taken by server to fetch the resource. Yeah. So response time can include network delay. So this T1 is network delay, means time taken by network to pass on the information to server. Server processing time. Now again there are a lot of split ups of time, because when I send something to server is not going to respond to me directly. There is something called connection. Every client has to make a connection with server. It's called hi hello. Hello, I'm this introduction. Server will say, okay, I know you. What do you want? They will establish a connection. Then server will send it. So there will be some session IDs passed, which will be very interesting to see when we look at correlation, right? So server will not entertain any browser request. It will say, okay, are you authentic? Okay, then only I'll listen to you. Then when it reaches the browser will have its own rendering time. Browser will take few milliseconds because it will be receiving raw packets right from the network. So they need to be displayed to you in the form of proper tables or whatever color, text, images, whatever your website looks like. So browser will need spend some time in receiving the data, working it out, and then displaying back to you. So all that is included as a part of response time, because for me, till I don't see that image which I requested, I'm waiting. So we will look at it in more detail, this typical interaction. We will look at HTTP protocol, how it works. Yeah, because it is very important for any performance test engineer to understand how a protocol works. Any questions on this?
Sir, if there are multiple systems involved, then the response time will be calculated for all those systems. Like when we make a payment, there is a gateway.
Yes, absolutely correct.
Okay.
So basically, I'm just showing one server here. That server may be talking to some other systems.
Yes.
So that also will be part of your response time, because you're waiting. For you don't know what's happening, right? For an observer, they have no clue how many systems server is talking to, how many hops, network hops it is making and all. But you're waiting. So for you, it is all part of response time.
Okay.
Okay, any questions, Archana, which you have not understood?
Sir, observer is also there is more than one.
Sorry, can you repeat your question?
You show there one observer.
Mhm.
There is more than one also.
But how will that change the response time? Because observer is not doing anything.
No, sir.
So what I understand what you're trying to say. So this server may be responding to other observers also.
Yes.
So they will be there having one response time. So for example, if I draw one more observer here, server, so obviously server will not be only responding to one request. Now, how many of you are using Amazon at the same time? So Amazon server is dealing with each one of us,
Yes.
right? So every observer will be able to see, okay, I pressed click button, now I'm seeing the image. So if there is another observer, he may have different response time based on his network, bandwidth and all that.
Yeah.
Okay, so this is just for one observer I'm showing. There can be n number of observers and there will be in fact.
Yes.
So each observer will have its own set of values for response time based on his broadband connection, based on the time on the day. For example, if I do it in the night, maybe my response time would be faster because there is not much network traffic. If I do it in the peak hours during the flash sale, maybe I have to wait because there are so many observers connecting with the system. So observer is just, don't get confused. Observer is any user. Okay. So I will actually change it right away because I will call it as a user. Okay. All right. So feel free to ask any question. Okay. Don't hesitate. No question is wrong.
Yes, sir.
All right. Next is latency. So as we saw, right, there is time required for these data packets to flow over the network to its destination. So that is called latency, how much time it takes. Time delay in receiving data signal in a network. Latency measures the time it takes from some data to get into destination across the network. Yeah, so suppose if I click an enter button here, it will reach to Amazon server. The time it will take is a latency, right? One-way latency. Then there will be server processing, then server will send me details. Again, it will take some time to reach out to my browser, get it displayed here. Next term is view user, very important term. Yeah, you will not be talking of users when you do performance testing. You will say view users. View user is a virtual user, is an artificial user, a kind of thread created by performance testing tool which simulates the real user action. So when I'm saying that, for my bank, there are 600 users. When we do performance testing, my tool will be creating 600 view users, 600 threads will be created by my tool. Each thread will simulate user actions, right? So for example, user one says, I'll log in, I'll click on credit card statement, I will check my balance, I will log out. Another user will say, no, I want to transfer money, I want to pay bills, I want to log out. Third user will say, I just want to log in, check the balance, log out. So all those users will be simulating those actions. Yeah. So user simulating a flight booking transactions will actually book a flight the way actual user will book. No change. It will enter the address, it will enter the name, it will enter the amount, credit card details, it will click submit button, and the flight booking transaction will get completed. Obviously, it is on performance test environment, so we don't want, it's not a production environment. but then exactly it will do the same thing as the way the user will do it on production. Any questions on the user?
No, sir.
No, sir.
Okay. Next is pacing time. Now, you will need to be very clear on what is pacing time. So pacing time is a time delay between two iterations of a transactions for same user during performance test execution. So you will come across this pacing time when you will be setting up your scenario for performance test execution. Okay, your lead will say, "Arey, you increase the pacing time or you reduce the pacing time." What does that mean? So what I'm saying here, now let us say we started executing. Okay, so observation time starts here, observation time ends here. Okay, so during that time, we have 3 iterations of book flight: book flight 1, book flight 2, book flight 3, same user. Okay, so user is booking flight, logging out. User is logging in, booking flight, logging out. User is logging in, booking flight, logging out. Okay, but then user is not doing it continuously. Okay, so what we are doing, we are keeping some spacing or pacing between 2 iterations. So user will complete on iteration, user will not start immediately. User will start only after this pacing time, right? So let us say pacing time is 2 seconds. So user will complete one iteration, wait for 2 seconds, again start iteration, complete the iteration. That is, iteration means the operation which it is supposed to do, that is an iteration. So complete execution of one script. So this script does book flight. So it will log in, book the flight, log out. That is one iteration. Wait for 2 seconds, log in, book the flight, log out. Again wait for 2 seconds, log in, book flight, log out. That is iteration 3. So this time delay between 2 iterations is called pacing time. Okay. Now, in this observation time, I am able to complete 3 iterations of book flight. Okay, this is 2 seconds, let us say, and this is also 2 seconds. Now, if I increase this pacing time, okay, then what do you think? Will I be able to fit 3 iterations of book flight, or will I be able to fit less or more iterations if I increase this pacing time?
Less iterations, sir.
Correct, because I'm asking it to wait for more, right? So if I increase this more, maybe I'll say iteration 1, lot of pacing time, and then iteration 2 only. I can't fit iteration 3 in this given observation time. If I reduce this pacing time, maybe I can fit one more iteration, because then I'm waiting less, I'm immediately starting, let us say. So if we increase pacing time, so basically for this observation time, how many transactions are getting completed for book flight? 3 transactions. If I increase pacing time, I will get less transactions. If I reduce pacing time, I will get more transactions. Correct? In a given time. So if I increase pacing time, will my throughput go up or go down? Archana? I'm increasing pacing time. Okay, my throughput, let us say this is 1 second, okay, time. Or let's not even talk about that. Let's say in given time, I'm able to complete 3 iterations of book flight transaction. Now I'm increasing this pacing time. So will I be able to fit 3 transactions of book flight, or less transactions of book flight, or more transactions of book flight?
Less transaction.
Correct. Because I'm asking it to wait. Okay. So less
Why
transactions.
we require that the pacing time?
Yeah. So I will explain this when we will execute a load test. Why we need pacing time.
Okay.
Yeah. So pacing time is a facility for us to work around with the throughput. So if I increase pacing time, my throughput will reduce, correct? Because I'm increasing the wait time. If I reduce pacing time, my throughput will go up. Are you all with me?
Yes, sir.
Yes, sir.
Yes.
Archana, Manisha?
Yes, sir.
Yes, sir.
Okay, so why and that I will explain later. Right now, we just need to understand this. Pacing time, more the pacing time, less the throughput, less the pacing time, more they're inversely proportional. Yeah, so I'll put it that way here. So what do we write? Inversely proportional 1 upon throughput. Correct? Okay. Let's move on. Next is think time. Now this is a tricky concept, but once you understand, it's very easy. Okay. So think time is time taken by user before browser or UI send request to server. For example, submit form, click login button, and it helps to simulate actual user behavior. Okay, now let's take this example. Okay, so we have a landing page of an application. Okay, on this landing page, we have to enter login credentials. Then the home page get displayed, and then user search the product. Now, when we log into this application, when the landing page is displayed, okay, you are entering login credentials. Maybe you take 7 seconds, because you enter login, then you click on the password, you enter the password, and then you click on the submit button, correct? And then home page gets displayed. Now on home page, you read something, and then you start searching the product. So from a server perspective, when landing page got displayed, server was waiting for 7 seconds, right? Because you were entering the login credential. When you clicked, immediately request went to server. Server displayed homepage. Now you're reading, right? Because on homepage, a lot of advertisements, some instructions, correct? Then you enter the product search. Maybe, so basically you're reading some text on homepage, right? There are some new sales. There is some information about, the other products, some discounts. So you spend around 10 seconds in that. Then you enter product for 3 seconds and you press enter, the search product. So now server knows that you're trying to search the product. Okay. So these 7 seconds which you took to enter the login details, this 13 seconds which you took to read stuff on homepage, to enter product, server was not doing anything, correct? Even user also was not doing anything, because user was entering the login credential, but unless you click submit button, it will not go to server, correct? Hello.
Yes, sir.
Yes, sir.
Correct. So imagine that the landing page is loaded. I mean, you clicked on that website. Now landing page is there. You enter login details. You enter the password. You press enter. The home page get displayed. Now you read some text. You enter product and you again press search product. So this 7 second, you were thinking. The server says, boss, user is thinking, because server doesn't know that you are entering the details, right? Unless you click submit, server will not come to know that these details were entered. So this is called think time. So from a server perspective, user was not doing any actions. So I mean, these are such some numbers I have taken. Okay, you may take 5 seconds. That's okay. So I've just taken 7 seconds as an average person who will type and all. This 13 seconds, someone may spend 5 seconds only, no problem. So read homepage text 10 seconds. If there are no advertisement, you will say, no, I don't want to read anything. I'm simply entering the product search and I'm pressing the search product button. So this think time may vary from user to user. Are you with me?
Yes, sir.
Correct?
Yes.
Maybe Archana will say, no, I'm interested. She may spend 20 seconds here. So this become 23. So when Archana is trying to use that, Amazon says for 23 seconds, I'm not receiving anything, right? So that means user is thinking from the server perspective. So user may be entering something, but then unless that submit button is clicked, server will not know it. So server says user is thinking.
Basically, sir, it is totally depends on the user, how
Correct.
much time they taken for this.
Correct. So it is basically time taken between the user actions of submitting and sending something to server.
Yeah.
Okay. So these numbers I have just taken so that you get a feel. Okay. For example, if we all of 4 actually log into e-commerce website by entering login credentials and password, maybe I'll be able to complete this in 8 seconds. I don't want to read any advertisements. I'll be able to have this in 5 seconds. Maybe Manisha will say logging in 3 seconds because her maybe typing is fast. But then she spends 30 seconds reading the advertisement. And then she starts searching the product. So the think time changes from user to user. Okay, but as we are simulating the user actions, we should know what these think times are. Then only you'll be able to put this in your load test, isn't it? So that's why you should understand the behavior of the user, and think time will help you to understand the behavior of the user. So it helps to simulate. So once I know, so what I will do, I will take the average. I'll say, okay, on an average, every user takes 5 seconds to enter the login credentials. Okay. So what I will do, I will ask my tool to wait for 5 seconds here. How do we use this in performance testing? Because we are sending this by tool. So tool will not take even 1 second to enter these details, right? It will be milliseconds tool will be entering. But then we will need to tell the tool, wait for 5 seconds because user takes 5 seconds for clicking the button. So our tool needs to wait. On homepage, when it gets displayed, on an average, we say user spends, let us say 10 seconds. So we will need to tell our tool, once the homepage gets displayed, don't click immediately on search button, wait for 10 seconds. Then click on search button because then you will simulate the user behavior, correct?
Yes, sir.
Yes, sir.
So that's why understanding of think time is very important. And when we actually do performance testing, we randomize this so that then we simulate different types of users. But then we need to know some basic numbers. Then only we can randomize them. Okay, so think time clear. Now you think about this so that you will understand.
The same should be whenever we are using any app at that time, many times or any browser, and many times our password and mail ID are saved. Just we have to click it.
Correct.
So for that also we have to test that thing.
Correct. So that's the reason we randomize it. Some users would have it saved. Some users would not have it saved.
Right.
So we have to have a collective simulation of all the users, not just the users who have saved it. That's the reason we randomize it.
So we have to create different scenarios and we have to write the different scenarios for the test, right?
No. So our tool has an ability to randomize the think time for every user.
Okay.
That's where the ability of the tool will come into picture.
That is good. Thank you, sir.
Sir, Is it similar to the concept we used to use in Selenium, like implicit wait, explicit wait time?
Not exactly. See, implicit wait and explicit wait are there to synchronize because server is slow and Selenium script is fast.
Yes.
So your Selenium script will come and try to click on a button when the button is not there. That's why we ask him to wait.
Correct.
Okay, that has nothing to do with the server action, user actions. So in automation, we will not bother about think time. In automation, we'll click on landing page, we'll click on home page, we'll click on search button, because we want to save time in automation.
Correct. Yes.
Here we want to simulate the user behavior. That's the difference.
Okay. Okay, so I got it.
So that's the reason the manual script which you execute in 10 minutes, your automated script will execute in 10 seconds because it says I am super fast. I'm
Correct,
entering
yes.
user ID password in milliseconds. I'm clicking on the button, but then because it is fast, it cannot cope up with the server responses because server is slow, the network delays and all that stuff. That's why we need to tell our Selenium WebDriver that you have to wait for 5 seconds so that the object will appear. Now you go and click on it.
Yes, correct. Okay, so I got it. Thank you.
Yeah. Now, next concept is very important. You'll be questioned on this in interview. Okay, 90th percentile is a value below which 90% of the samples fall. Very simple. So, if these are the samples, now arrange them in ascending order. Okay, for example, these are the response time samples. So, some response time is 0.5 seconds, some is 10 seconds, some is 7. So, what I did, I collected all those samples of response time. I arranged them in ascending order. So now they are randomly organized, right? Now first recording may be the last, the second may be the 7th, the ninth reading may become 90th reading in this when I arrange them in ascending order. Correct. Now what I'm doing after I put them in ascending order, I actually say 90% of this. Okay, so these are 100 transactions, let us say. So I go to 90th transaction here. I go to this and I say this value is my 90th percentile value. Okay, so what I can claim, let us say this 90th percentile value is 7 seconds. So what I will say, 90% of my response time are less than equal to 7 seconds. And 10% of my response time are higher than 7 seconds. Any questions? So 90th percentile, what we do, we arrange all the samples or all the recording or whatever, response time numbers we have in ascending order. And we, out of those, let us say we have 1,000 transactions, okay, collected. So I will go to 900 transactions here. And then I will take the value corresponding to that 900 transactions. So let us say 17 seconds, we have 1,000 transactions. I arrange them in ascending order. The highest is 20 seconds. Yeah. And for 900 transactions, here I pick and choose. I go and check, okay, it is 17 seconds. So what I can make a statement that 90% of my response time readings are less than 17 seconds. Only 100 readings, that is 10%, are higher than 17 seconds. Are you with me?
Yes, sir.
Yes, I got it.
Can
Archana?
you repeat?
Okay. So what we are saying, we are not bothered about the sequence of capturing the transactions because we are arranging them in ascending order. Okay. So let us say I observed a response time of a website for 2 minutes, let us say. Yeah. And I actually fired 1,000 times I tried to load the website. I'll get different readings of, for each, each time I tried to load the website, how much time it took. So I got 1,000 such readings. What I will do, I have 1,000 readings. I'll arrange them in ascending order. Okay. Now, because I have got 1,000 readings, I will go to my 900 transaction because that is 90% of 1,000, correct? So 900 transaction, because they're in ascending order, I know that when I look at this number, all the rest of the 900 transactions will be less than this number, correct? Because it is in ascending order,
Yeah.
right? So 90th percentile of this population will be one number, and I will say that 90% of my reading are less than that number. That number can be anything, 17 seconds, 5 seconds, 20 seconds. Yeah, so I will revisit this when we, talk of statistics, and then we will solve some examples so that you will get a clarity.
Okay, sir.
So right now what you need to remember, 90th percentile is the value of the observation below which 90% of the sample will fall. So 90% of the sample will be less than this value. Okay. Any questions?
Sir, we take only for 90%, 90%.
Yeah. So this is a standard, industry standard, that they look for 90th percentile. If your client tells you give me 95th percentile, then what you will do? Let us say you get 1,000 transactions, so you will go to 950 transaction. Yeah, which is in this, and then you will say, okay, this is a 95th percentile value. So you can calculate 50th percentile value also, no issues.
Oh, okay.
Okay. Now I'll give you a simple example. You all would have attended competitive exams. Nowadays we get percentile. What is 90 percentile? That 90% of the students are behind me. That is the way, that's the reason I got 90th percentile, because they got less than my marks, 90% of the students. Correct? If someone says my percentile is 95 percentile I got. So what is he telling you? That 95% of the student who appeared for exam. So let us say 1 lakh students appeared for exam. So out of that 1 lakh, 95% of the student got less mark than me. That's why I'm a 95th percentile student. Got it?
Yes,
Yes, sir.
So we use it, but we don't realize exactly what the meaning of it is. So the person who got 100 percentile, he will not, because he'll get 99.99, because he himself is also part of population. So he'll say, boss, I'm the topper. Yeah, because I got 99.99 percentile or 100 percentile, whatever. Okay, shall we move on?
Yes.
Sir, just one question.
Yeah.
It means if the value is less than 90%, is it good, or I'm not getting that thing.
So basically right now what we are saying that this is the 90th percentile value. Let us say this is 5 seconds, okay, for our population.
Right.
So what does this tell us? That if I execute this particular transaction, okay, n number of times, 90% of the time I'm going to get response time which is 5 or less.
Right.
So that gives me more confidence that only 10% times I will get higher response time, which is okay.
Okay.
Yeah. So
Right.
90th percentile is more stringent than average.
Okay. Got it, sir.
Okay. All right, now some more details. So there are some performance laws which we'll also have a look at it. You should at least know what those laws are. Okay, so Little's law is very famous, which is very regularly used in performance testing when we do calculation on workload model or other calculations basically. Okay, so but there are a few other concepts. So service center is a place where the work gets done. It can be processing, writing in terms of computer. Okay, so it can be CPU, it can be a process, it can be disk, because they do something, right? So any component of your software, hardware, is a service center because it receives input, does some processing, gives output. So that is called service center. Yeah, so it can be a CPU, it can be a processor, it can be a process, or it can be disk. Yeah, because there will be, so you receive something, either you write or you compute or you output, right? So some input, some processing, and there is an output. Service time is time required to complete a task. So you received something at T1, processing is done, the output is given at T3. So T3 minus T1 is a service time. Yeah, so this is new concept. Just right now, just hear it out, and then you can start thinking about it. So when we do some performance engineering kind of stuff, we need to be clear about this. What is a service center, what is a service time, and all that stuff. Yeah, but as a performance test engineer, you should know this. Shall I move on?
Yes, sir.
So basically, any part of your hardware will be a service center because it is receiving something, is doing some processing, sending some output. Yeah, so it may receive input, it will write something to some other disk or something, and it will give you output. Yes, it is written, right? Some confirmation, or maybe it will send the data back to next. It can be anything, but it is doing some processing as a part of your whole application. And the time it takes to complete one processing, T1, T3 minus T1 is service time.
Sir, is it similar to the response time you mentioned earlier?
So the response time is from the perspective of the user.
Okay.
Yeah, but then this service time will all get added to your response time because these are the components of your hardware which are working on it, right?
Yes.
So your response time will be comprising of all the service time of all the components plus many other times.
Okay. Got it.
Okay, now this is little tricky. CPU utilization, pay your maximum attention. CPU utilization is a measure of time for which CPU has been busy, measured per unit time, expressed as a percentage of time. Let me make it simple English. It is different sentence. So what we are saying, when I say CPU utilization, I am talking of a unit time. How much within that unit time my CPU was busy. Now let's look at some maths. This is a CPU. I'm receiving 10 requests per second. Okay, the capacity of this CPU. Now we know based on the CPU type, the make, the brand, the capacity can be different. So this CPU has a capacity of 50 requests per second it can process of this kind. Whatever the type of request it is receiving, this CPU has an ability to process such 50 requests. But then the rest of the system is sending only 10 requests per second to this CPU. So what will happen? Per second receiving 10 requests, but it can process 50 requests. So what will happen? It has a capacity to process 50, receiving 10. So it is utilized only 20% per second. So if you observe this CPU for 1 second, 0.2 seconds it will be busy, and 0.8 seconds it will be idle, because it says, oh, I have already completed the processing. I am waiting for next request. Because we can send only 10 requests to the CPU, but it has got capacity of 50. So 50 is the capacity, 10 it is processing, right? That's why utilization is 20%. This is always on a unit time basis. Yeah, so my CPU utilization is 20%, means in any given 1 second, if I split that second into 1000 milliseconds, my CPU is only busy with 200 milliseconds. 800 milliseconds, it is idle because it has done the job already. Now let's look at this. The same CPU, now we are sending 25 requests per second. Now CPU will get utilized to 50%. So in any given 1 second, it has a capacity of 50 requests being processed. It is receiving 25. So even 1 second, half the second it will process those requests, half the second it will be idle. That is 50% utilization. Are you with me,
Yes, sir.
Yes, sir.
Yeah, yes, sir.
Archana?
Yes, sir.
Okay. So Archana, I'll be taking your name more. Yeah, because not because because you're a fresher. So you have to relate many things. Others have experience. Yeah, so that's out of concern. I'm asking you. Don't take it in a negative way. Yeah.
No, sir, no problem.
Okay, cool. Yeah, because if you understand, all will understand.
Yeah. Yeah, okay.
All right. So 20%, 50%. So that means CPU can also become 100% utilized, which is very bad condition, because the moment CPU gets utilized 100%, your system will be stalled because it has no processing capacity left. It says, I'm completely busy. Any new request you send me, yet it has to wait. I'll cover that. Yeah, what is saturation? Okay, now this is memory utilization. So CPU utilization is clear. It is always on a time basis, CPU utilization. Memory utilization, nothing to do with time. I've shown this from my laptop only, the memory usage. Yeah, so it has 15.8 GB available. This is utilized 9.9 GB. So 62% is a memory utilization. At that instance, it will keep on changing. Yeah, so
Yes.
memory utilization is relatively easy to understand. Total available memory and how much is utilized. Take a percentage. Okay, next is concurrent users. So we refer to concurrent users in the definition of performance testing. Yeah, so these are number of users logged in a system at any given point of time. So for example, this is a system. Login 1, login 2, login n. So there are n number of users which are concurrent. Now there is one more term which is not very widely used in IT, but maybe it's good to know. Okay, but what you should be very clear is with concurrent users. Yeah. Now, out of this concurrent, all are not actively using the system. Some are idle. Maybe I have logged in, but then I'm not doing anything. I'm doing something else. So those users called active users. Because so concurrent users are total which are logged in. So they have established a connection with the system. They're using, that connection pool. Not all are active. Some of them are actively logging, trying to use the system, place an order, search something. Some are not active. They are just logged in and they are doing something else. Maybe you got a phone call. You have logged in and you're not doing anything. Yeah. So you are a concurrent user, but you are not an active user. Yeah,
Yes,
any questions?
No, sir.
Okay.
sir, just one question.
Mhm.
Concurrent user is fine, but what about CPU utilization, memory utilization? Is this is important in performance testing, sir?
Yeah, it is definitely important.
But how come we should know the input, how much input we are giving to the CPU and what output is coming for the users and everyone?
No, so that was just for the understanding.
Okay.
In performance testing, you will not be looking at individual CPUs, you will be looking at a whole system.
Okay.
Okay, and there are monitors available which will tell you how much CPU, how much memory. That is
Mhm.
part of monitoring.
Okay.
Yeah, so you will collectively see, not at very individual CPU level.
Mhm.
So we can always drill down, but then that requires a lot of high end skills in engineering, performance engineering.
Okay.
Okay. Yeah. So I think, shall we take another 5 minutes break? It's another hour.
Yes.
Yes.
Yes,
I'll
sir.
be back at
Yes, sir.
12:38.
Yes, sir.
Okay.
Okay. Now, average we all know, it's a statistical average. You sum up all and divide by number of observations. Yes. So next is rendering time. So rendering time is a browser side processing, of the page content. I said, when we looked at response time definition, when data packets are received from the server, they cannot be displayed as it is. So browser has to do a lot of things. Yeah, so browser has something called rendering engine, which translates data packets into text, images. So that someone needs to do that, right? Because server will not be sending you all that. Server will send you the data packets. So who will do that? So that is done by browser. So browser is a very complex software. Yeah, seemingly it seems very easy to click on a Chrome and open it. I mean, a lot of things go behind the scene, right? It will do HTML parsing, CSS parsing, create render tree, JavaScript interpreter, painting, a lot of things will go behind. Okay, and so browser, obviously it will not be 5 seconds, 10 seconds. It will happen in few hundred milliseconds, basically. Yeah, it's very fast. Okay, but when we do performance testing using tool, this rendering time is not part of the response time. Now I'll explain this little later why. Yeah, because browser itself is not part of the performance testing execution when we do it. Just a minute. Huh? Yeah. Okay, so rendering time is only for information, because when we will do performance testing using any tool, this rendering time will not be part of our response times. Yeah, but then definitely browser spends some time in terms of receiving this data byte and data packets. Once they are received, it needs to do so many things. I have not listed many things here. Okay, but still HTML, CSS, create render tree, JavaScript interpreter, painting, lot of things will go behind the scene. Okay, so rendering time is part of the browser processing time. It's after receiving the packets, the rendering time, and then you will actually see the picture on your website. Okay, or on your screen, basically. Okay, now this is concept of scalability. Okay, now scalability, system is scalable when response time, system utilization remains stable and does not increase in direct proportion to increase in load. No, we'll try to understand this using simple graphs. Visuals are always better. Yeah, so on y-axis here, we have put response time, system utilizations. On x-axis, the number of users, the transactions, right? So obviously, when the users and transactions will go up, the response time also will go up, right? Because system will get loaded. The utilization also will go up. Are you with me?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Now, if we plot a graph, maybe it will become a straight line. Okay. So there are two systems, S1 and S2. Now, what we are saying, S1 graph is little flatter than S2 graph. Yeah. So the gradient is more for S2. So if I say that, so we're trying to find out the slope. So that is delta R1, right? So difference between this R2 and R1 response time. And let us say users. Yeah. So U2 minus U1. So what we are saying, because delta R2 is greater than delta R1, this gradient is more. Correct. So for the same delta U, delta R2 upon delta U is greater than delta R1 upon delta U, because delta R2 is greater than delta R. With me?
Yes.
Yes, sir.
Okay. Now, based on this, I will make a statement that system S1 is more scalable than system S2, because for the same increase in number of users, the increase in response time is lesser for S2 as compared to S1.
Right.
So if I increase the same number of users on both systems, I am seeing S2 getting a lot more slower than S1 for the same number of increase in users. So that means S1 is more scalable because it is able to scale up with more number of users. So it is always a comparison. Scalability is a comparison. It is never absolute. So what I make a statement, S2 is less scalable than S1 because it actually increased the response time a lot more for the same number of users as compared to S1. Now, if I draw another flatter graph here called S3, I would say S3 is more scalable than S1.
Yes.
Now, when you actually plot them in actual, they will not be straight line. This was just for our understanding. So if you plot the same, maybe you will get some parabolic graph for 1, for 2. But obviously the slope and the gradient will tell us which one is more scalable. So lesser the gradient here, more scalable it is, because more number of users, it is not increasing to the tune of what it is increasing for 2 because the gradient is small here. Okay. So scalability is relative. When we say one system is scalable as compared to other, that means with increase in load, it is having less increase in response time and other system utilizations as compared to other system. Any questions on this?
No, sir.
No, sir.
No, sir.
Right. Let's move on. Okay. Now there is a concept of saturation. Saturation is state where the service center, this is a service center. We looked at that definition. Is utilized to full capacity, then it will become 100% utilized. So for example, capacity of 50 requests being received, CPU is fully utilized. So if you observe it for 1 second, you will say CPU is always busy throughout 1 second. Correct? Now, in place of 50 requests, we start sending 60 requests per second. But utilization cannot go beyond 100, right? So what we will observe is that 60 requests are received every second, 50 requests are being processed, so 10 requests are in waiting. So the moment there is a waiting, the performance start degrading because there is a wait time, lot of wait time in the system. Yeah, so saturation means where the service center, typical CPU, when the memory becomes 100% utilized, your system will become slow because there is no memory for system to create object, right? System needs memory, isn't it? Just give me a minute. Huh? Yeah, okay, I'm back. Right, so if more requests are being sent, anyway, CPU says I can't handle, you have to wait. So maybe next second it will start processing this 10 requests. So every second there will be 10 requests waiting or getting added rather. Yeah, so it will form a long queue before the CPU with all the requests. Because next second it will send 10 more requests, next second it will send 10 more requests. So it will keep on sending. So the request will form a queue, right? So this CPU will keep on processing continuously, but still the requests are waiting. So that's not good. That means it will lead to bad performance basically. Okay, shall I move on?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Now let's look at some basic terminology. Web server is a primary function. So web server is the server which will handle all the pages for you, HTML request, right? And it will talk to other servers. It will talk to application server. So web server will be giving you all the pages which you see, right? So this is a browser, HTTP request sent. These are the files, the servers, all the data. It will respond you and it will be shown on your browser. So Apache web server is most popular and Nginx is next in preference. Yeah, so Apache web server obviously will be open source. As the name says, Apache is a group, right? There are a lot of Apache groups. For JMeter also is Apache JMeter. So dynamic, so web server will be typically static. If it requires any calculation, it will typically send it to application server, So business processing will happen on application server. On web server, it will be typically, stacking the content which needs to be displayed. So whatever it receives from application server, it will display it to the browser or a user. Application server enables server to generate dynamic customized response, right? So all the processing, the business rules application, the logic, that all will reside on application server. Okay, so some of the services offered by application server are clustering because they are doing business processing, right? So they will be more busy than the web server. So you need more application server sometimes. Right, so you will need to do clustering, you will need to do balance the load because you're sending the request to two different application servers, etc. Now, some of the examples of applications, the JBoss is one application server which is open source. Glassfish is provided by Sun Microsystems. WebLogic is by Oracle and WebSphere. So you will come across when you join a performance testing project, you will say, okay, we have a web server from WebSphere or application server from WebLogic, like that. So the way we have application server and web server, we have got database server, right? Which is a server which connects to a database, which runs all the SQL queries, right? So user accesses a database server either through a front end, running the user's computer, which displays requested data, or through backend, which runs on the server. So some of the examples are Oracle, DB2, Informix, NoSQL, Microsoft SQL, MongoDB. These are some of the database applications or servers basically. you will come across load balancing. You know, whenever there are more than one servers processing, there needs to be a load balancer in between, you know, so that it will give equal load to both the servers. Otherwise, typical one server will get loaded, other server will be idle. So that's not what we want. So it refers to process of distributing set of tasks over a set of resources. And so for example, if you see here, there are two application servers. So this is a load balancer. So whatever users are sending to web server will send it to load balancer. Load balancer will keep on sending them. There are a lot of algorithms which are, you know, you can configure this load balancer with. So this load balancer will ensure that these two servers are evenly loaded, so that, you know, we get the better performance and better output. And then they will talk to individual single database server. Yeah, so it acts as a reverse proxy and all, that's okay. But then main work of load balancer is to distribute the work among the whatever application server or other entities it is sending the work to. Caching is a storage layer which stores the data. You know, now, for example, if there are a lot of static content, so what our browser will do, our browser will start caching them. It will not go to server every time because it knows it's a static data. So while caching, what happens is the response time become faster, you know, because the browser will not go to server every time. It says, no, I know the image. There is no change. You just take it from me, right? So caching helps, but it helps whenever there is a static data. For dynamic data, you cannot do caching because the data keeps on changing, right? You don't want to look at the old data. You want to look at the latest data. So whenever there is a lot of dynamic content, then this caching will not help. CDN, you will hear content delivery network. Okay, so these are geographically distributed group of servers that work together to provide faster delivery. So they will basically, for example, if I'm accessing an e-commerce website, you know, where the server and the data center is in, let us say, Europe somewhere. Okay, so what this CDN will do, they will actually give me some servers which are, you know, in APAC region. So I don't need to go to the Europe server every time. So they will keep on, you know, stacking the data from dynamic server from Europe, and they will keep on giving me. So naturally, the response time for server in Singapore would be better than server in Europe, right? Because of the network latency. So this CDN, there are a lot of companies, they provide this CDN, right? So they will host a server near to your location. Okay, and they will keep on interacting with the other servers and all. So they will give you faster response time. Any questions?
Sir, are these CDN similar to data centers? You can say.
Not data center will do lot much more than a CDN, right? CDN will just ensure that you get the content which locally to you. You know, you don't need to go to remote server and get it.
Okay.
As data centers will do a lot of other stuff also.
Correct.
So CDNs are meant to ensure that you get a better user experience. That's it.
Okay. Okay, sir, got it. Thank you.
Proxy server. Now, whenever you join any project, that company would have a proxy server, right? That will typically server through which all your internet requests will go. Yeah, so that routes all your requests, you know, between client and server. So basically, this is a company intranet. So they will have a proxy server. So all the requests will go through this proxy server to internet. They will not be allowed to directly connect to internet. Okay, so this gives a security mechanism for every company. Yeah, and basically it also do some caching. For example, if you're sending, requesting for some image, and the proxy server knows it is not changed, so proxy server will say, you take it from me, you don't go to internet, I have the image, you take it from me. So it will keep on caching some of the content also. Yeah, so it goes between end user and web pages they visit online. So every company would have. So this is typically, you can say, security also. Plus it provides caching and it provides control. So no one can directly access internet. They have to go through this proxy server. So all your computers will be configured to directly talk to proxy server first, and then proxy server will decide whether they can give you access to internet or not.
Sir, the caching server, it is used for security purpose. Do we use firewalls over there, like most
Correct.
of the time?
Yes, yes. Firewall also will be part of that only.
Okay. Most of the time in companies, we do see like the um, some of the sites are blocked.
Correct.
So, yeah.
Correct. And they will not allow you to go through some ports. Some ports are also blocked for security purpose.
Yes.
That's right.
Yep.
Okay, let's look at some architecture styles. So we have 2-tier, 3-tier. So basically web server is 1 tier, database server is another tier. So these are the users. So what is happening when your application is relatively simple, okay, not very complicated, does not require a lot of calculation, processing. So in that case, your web server would be able to handle some of those functions, and then it will interact with database server and it will give you the data. But as maybe your business becomes complex or you need a lot of computation, you need to add an application server in between. So you add one more tier, right? So this is a presentation layer. So now then web server will only responsible for displaying the content what it receives from the application server. So it will receive the request from the user, send it to application server will actually process it, will fetch some data on need basis, post some data on need basis, it will revert back with updated contents or results with web server will display it back. So 2-tier architecture will have web server and database server. 3-tier architecture will have web server, application server and database server. Okay, so these are the tiers, 1 tier, 2 tier. This is 1 tier, 2 tier, 3 tier. Yeah, so this is called presentation layer, business layer, because all the computation of business logic, business rules, everything would happen here. And data layer is for maintaining the data set, tables, schemas and all that. Any questions on this?
No, sir.
No, sir.
No, sir.
Okay, now let's look at another style of architecture called thin client architecture and thick client architecture. So we all are very much comfortable and used to this thin client architecture. So thin client means the browser which is residing on our machines is a thin client. Browser doesn't do a lot of calculation, right? Browser, what it will do, it will get the request, send it to the server. Server will do all the whatever necessary processing, right, computation, and it will send you back. So that's the reason it is called thin client. So its job is just to show as a window, right? Accept it, send it to server, whatever it receives from the server, send it back to the user. So these are thin clients. Now there are certain applications which are called thick client application. So in that case, what happens, this calculation ability, the computation and all is built into this client itself. That's why they are called thick client. They are not thin. So they have ability to process your request without sending it to the server. Those are called thick client. Yeah, why we should know this? Because there is difference in the way we do performance testing for thin client applications and performance testing. The methodology which we follow, the strategy will be different for thick client. So that's why you should know. So thick client means everything happens on the client. Yes, and there is only another database or storage server. So what will happen, because these clients are processing requests on their own, they have to sync up sometime, right? So they will be keep on sending all the requests to database server and they will get synced up. Right here, server is doing everything. So you don't need to worry about syncing up the data and all, because this has processed 50 requests, this has processed 10 requests. So they all need to go and reside in a database, right? For future use also. So thick client are the machines, they have ability to process all the requests on their own. Thin client, everything is sent to the server. Server will do the calculation, computation, processing, everything. Any questions on this?
Sir,
Wait.
client means computer only.
Yeah.
Uh-huh.
So, but in this case, now this browser and let us say I'm using a laptop. Okay. But on a laptop, I'm using browser to send everything to the server. My laptop is not doing anything, right?
So virtual machines, like kind of VM.
Not exactly. So whatever browsers you use on your machine, they're all thin clients.
Okay.
Now you will see majority of the applications would be thin client architecture. You will come across rarely thick client, but you should know that there are some architectures like this, in which everything will happen on those machines. Those machines have ability to process everything. Okay, and they will just sync up with their database on a regular basis.
Okay, sir.
Okay. Okay, these are the differences. So in thin client, bulk of the processing happens on server. In thick client, they are also called fat client. You know, there are different terminology people use. So bulk of the processing happens on the client side itself. So thin client will always need continuous server connection because it has no ability on its own. It will say, I'll receive, give me request, I'll send it to server. Server will process it. Whatever server sends back, I'll give it to you. So in thin client architecture, we need continuous server communication between client and the server. In thick client, we don't need because client itself is capable of processing the request. Right? So data validation, everything is done by server. Whereas data validation is done by thick client. So it has ability to do everything thick client. So more downtime on thin client because anytime network is down, you have a dependency, right? Server is down, network is down. The chances of the thin client architecture application being down will be more. A thick client, you have no dependency. Everything is on the same machine. These are cheaper to deploy because you don't need, right, any specific machines. A thick client, maybe you have to build those machines with specific capabilities. So that's the reason you will see less implementation of thick client architecture and more of thin client. Okay, next is synchronous processing and asynchronous processing. So in synchronous processing, basically we are expecting immediate feedback, right? Response back. So you click on a search button, you are expecting that you will get search results, right? On an e-commerce website. Now, when you send a mail, it's an asynchronous because I mean, you are not expecting whenever the user will read the mail, you will get the response. Similarly, SMS is a kind of asynchronous communication because I send an SMS. Okay. If that person is online or reading, he will reply. Otherwise, it just deliver it to him. But in synchronous processing, it's like a WhatsApp chat. Yeah, you send it, you see immediately person typing back. Correct. So in asynchronous, another example is NEFT transfer when you do online banking, right? You submit a request and after some time it will get processed. You don't immediately get the response back. Whereas IMPS may be synchronous processing because you immediately get an SMS within few seconds that your transaction is complete. Yeah. So in asynchronous processing, you know, the task returns the control immediately with the promise to execute and notify about the results later, callback typically, you know. So SMS, mail are asynchronous processing, whereas live chatting, browsing, they are synchronous processing. Connection time, the average time spent in establishing a TCP connection with the server. I told you know there are a lot of stuff goes on between the browser, the client and the server. Server will not directly start talking to you. You have to establish a connection. There will be some handshake happening. Server will say, okay, you are the genuine client. Let's start talking. Another term is memory leak. So when expected available memory for a program execution become less and less available, it is called memory leak. So for example, earlier I had got, let us say 16 GB memory when I started executing my program. Okay, program started executing, my memory went down to, let us say 10 GB because it started using it, right? A lot of objects got created and my memory got utilized in that. So from 16 GB now it is 10 GB. Okay. After 30 minutes I observe now it has become 8 GB. After 1 hour I observe it has become now 5 GB. So something continuously memory is getting reduced. That is not good, right? If memory remains steady, that means whatever objects I am creating, same are getting destroyed, the memory is getting recaptured, I am using the same memory back, right? So when there is a memory leak, that means there are objects which are not having any reference. So whenever you lost a reference to object, you can't use the object in Java. But those objects will keep on blocking the memory, right? So it's a bad programming practice that you create an object and the reference is lost. So those are called orphan objects. So when you have such a lot of orphan objects, the memory is blocked because those objects are not destroyed, right? So ideally, when you create an object, you have to destroy the object. Right? I mean, its life is over, that object should go off. But then if the reference is lost, you can't connect with that object. Yeah, so in Java, there is a process called garbage collection. So when, when JVM realizes that there is a lot of memory which is unused, I mean, blocked in objects, it will actually execute garbage collection. So it will free up all the memory and it will destroy. Destroy means it will remove from the memory all these unreferenced and orphaned objects. Yeah, so when you will go towards the higher end of performance testing towards engineering, you will need to do a lot of this thread dump analysis, garbage collection analysis. So right now you can just, know it as a process that something like garbage collection happens whenever there is unused memory, yeah, which is blocked by code. Heap memory is actually a large pool of memory from which the running programs can request chunks, and objects are created in heap memory. Yeah, so this is where your memory will start leaking if the objects are created, but they are not destroyed, and new objects get created. So you consume, keep on consuming heap memory, and less memory is available for you. And then your program will stall at one point of time saying that there is no memory to create new objects. And when it stalls, that means it's a bad performance. Your program will hang. Okay, so I'll cover this slide and then we will stop today. I think I don't want to burden this. We will look at tomorrow. Yeah. So performance testing tool. What is performance testing tool? Right? It is an application or a collection of programs which has ability to generate multiple threads, wherein each thread represents one user of the application. This tool is configurable in terms of number of threads, duration of running the threads. We also saw, it can actually configure think time. I'll add that. And there are two types of performance testing tools or any tools. One are called licensed and open source. This is based on the licensing model. So licensed tools are LoadRunner, Tricentis, Neoload. So you have to pay. These are the companies which have developed these tools. Okay, so they say that you pay us money, you can use the tool. So these fees are pretty high, because these tools are very niche tools, right? When you will learn LoadRunner, you will see, boss, what all capabilities it has. Fantastic, right? So they would have spent resources, money in building this tool. So they say that you pay us the license fees and we will let you use it. On the other hand, there are open source tools like JMeter. Yeah, so there are people who came together, they built a tool and it is open for everyone. Anyone can download the code. Anyone can modify the code. Only condition is that it should be freely available to others. Suppose if I add new functionality in JMeter, I will not be able to make money on that because that's the license of Apache. They say that you can modify it, but everyone will use it for free. That's called open source. Yeah. Performance test data. Now we know all test data we need, right, while doing functional testing. Yeah, so but for performance testing, we need huge amount of data, huge, right? So whatever data we need to execute a performance test is called performance test data. Right now, there are typical two types of performance test data you will need. One is called master data. This data does not change, right? For example, your bank account number, credit card number, flight ID, or city names, they will be your master data because those are the physical entities actually. Transactional data, this gets generated during the usage of any software or business process. For example, PO numbers, if you just create a PO number will get created. That's not a master data, that is a transactional data. Or amount of money transferred, that is a transactional data. And flight reservation number, so that will get generated when I will book a flight, right? So these city names will never change, they are master data. But whenever I'm booking a flight, I will get a reservation number, that is a transactional data, or vaccination certificate number, another transactional data, right? So whenever I take a vaccination, I will get new certificate, that is a transactional data. Yeah, so transactional data is required in huge quantities. Yeah. Next is communication protocol. So communication protocol defines the way in which two systems or components talk to each other. Typical IT systems I'm talking. There are different types of protocol like web HTTP, HTML, web services, Citrix, SAP, Oracle, NCA. Yeah, these are all types of protocols. You will come across them in your career as a performance tester. And they all are different and challenging. Yeah, there are standards, to define. So how a typical HTTP protocol should work, how a web service protocol should work. There are international standards, right? Otherwise, everyone would have its own implementation, but that is not acceptable, right? So people or developers or whole the community of developers, whole IT community, they will look at these standards, and based on that, they will design their, applications and the way they will talk to each other. Yeah, so I think we will take a pause here today. Almost 3 hours, 15 minutes less to 3 hours, and I don't want to overburden you with the types of tests. So this we can discuss tomorrow. Yeah, there are a lot of stuff to understand in this also. So what I will do, I'll send you assignment only till this communication protocol. Yeah. And for the types of test, I'll give you assignment tomorrow, or you can skip those questions only, from today's assignment, which I have not covered. Okay.
Okay, sir.
Okay, sir.
Yes,
So hope you got to know many new stuff today.
yes.
Yes, sir.
Yes, sir.
All right. So just get going, go through it, understand, ask me questions tomorrow. Solve the assignment. We will anyway solve the assignment tomorrow at the start, and then I'll cover this test, and then we will start with our next performance testing life cycle.
Okay, sir.
Okay, bye.
Yeah,
Sir,
bye.
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 Bye everyone. Yeah, bye.
Bye, everyone.